Textbook ask us to find the limit as x approaches positive infinity. Oh, this is a good one. Of sine of x all over x. All right, shh. This one is easy to do. This one's easy to do. We said before that 1 over infinity is equal to 0. Right?
Yes.
So now, what is the range of sine of x?
0 to infinity.
Negative 1 to 1.
Oh.
Okay? So we could think that this is like negative 1 or one to infinity, right? So it's a very small number. Now there's numbers in between, right? There's numbers in between. It could be 0, it could be 1/2, it could be 2. So really, when we think in terms of infinity, any small constant over infinity will equal 0, right? If I take 8 pizzas and I divide them into infinitely many slices, the size of the slices are still going to be 0, nil.
3 pizzas, personal pizza, you really believe.
What?
I love your ability to totally go in the opposite direction of where I'm going.
I've been thinking that since you brought up pizza.
You just been thinking about pizza?
Yeah, well, I mean,
Okay, so
you're going to talk about it, and you're like, you split it up into 8 pieces, and then 16 is just too many. Like, it should really be.
What about it?
all right. So, anyways, what's the limit of this thing?
The limit does
0.
not exist.
Well, the limit should be 0, right? And so what we're going to do is, and you guys haven't heard about this yet, but we're going to apply. What we're going to say is, to do it a little more formally, it's called the sandwich theorem. And the sandwich theorem is that sine of x, whatever value that is bound between negative 1 over x and bound between positive 1 over x.
The sine of x over x is the mean.
So the sandwich theorem says, and I'll show you how to do this graphically in just a second, that the limit of this function as x approaches infinity of sine of x over x is equal to the limit of x has a limit of negative 1 over x as x approaches infinity, and the limit of positive 1 over x as x approaches infinity. And we just said that that is 0 and 0, right? That's what we just said. So what is the limit of this thing? If the function below is 0 and the function above is 0, then what is the limit of this? 0. Now here's how this is why we call it the sandwich theorem. Watch what I'm going to do. I'm going to graph negative 1 over x. So let's come in here and clear this out, and I'm going to say negative 1 divided by x. Okay? Then for my third function, I'm going to say 1 divided by x. And then in the middle, I'm going to put sine of x divided by x. And then I'm going to adjust my window, and I'm going to go 0 to, let's make it a really big number like 10.
100.
Oh, we'll make it like 1,000. And then my y value shouldn't be any lower than negative 1 and positive 1. So I'm going to say negative 1 and positive 1. And so let's look at this graphically. Yeah, maybe the x value is too wide. So let's come in, instead of doing 1,000, let's just do 10. because it shrinks quickly. What do you notice?
It hugs it. It sandwiches it.
It's a sandwich, right? So if I look at this graph, right? This graph right here, 1 over x, is an upper bound. The negative 1 over x is a lower bound, and guess what's trapped right in the middle? Sine of x over x. So as we approach, and let's zoom out just a little more, we'll go to like 20. And maybe I'll do like negative 0.5 and 0.5. Where is sine of x always going to be trapped?
In the middle.
In the middle. So as we go further and further out in the right direction towards positive infinity in the x direction, what is my sine of x going to do?
Be in the middle.
It's going to be in the middle. It's going to get smaller and smaller and smaller. And the reason for that is the behavior of sine of x. This is going to oscillate. The sine of x right here is going to oscillate between negative 1 and 1, but x is going to get bigger and bigger and bigger as we approach infinity. So over time, this has a dampening effect on the oscillation of sine of x. So essentially, you'll have like negative 1 over 100. And then positive 1 over 100. And then as x increases, you'll have negative 1 over 10,000. And positive 1 over 10,000. And so what happens graphically is this sine of x function just gets smaller and smaller and smaller, and it's bound by these two functions. So we use the sandwich theorem, and we say by sandwich theorem. And this is really helpful for those of you that are going to maybe possibly pursue Calc 2 in college for engineering purposes. If you can find any two functions, an upper bound and a lower bound, but they approach the same limit, you could do this with anything. And so you will do this a lot. You will do this a lot in Calc 2 and in Calc 3.
That sounds awesome. Yeah, it does.
See how I did that?